guys! Welcome back to science class! Today's video is about the 3 laws of motion. But what are the 3 laws of motion? So the first law is the law of inertia. And it states in this law that an object would remain at rest or in uniform motion unless acted upon an external force. First example, so you can really understand what the first law of motion means. The first example is your table. It's a very simple thing, and you know that there's stuff on your table. For example, this stuffed toy that I have right here, I can place it on this table and I can say that no matter what happens, no matter what time it is until I come back to this, that the stuffed toy will remain here. But how can I say that? It's because of the first law of motion. An object will stay in its place unless if I move it. That's how simple it is. So this stuffed toy here will stay here until I grab it or until I push it away, if I put it away here. And that's what the first statement of the first law of motion is trying to say. An object will stay in its place unless acted upon an external force or a movement. Imagine if you're late for school or for work, and you're on the highway and you really hope that there's no traffic so that you can get to your destination. Your car will keep moving until there's traffic, until there's more cars that you have to wait for. And your car stops because you hit the brakes. Doesn't that sound familiar? That sounds like the first law of motion. Your car will keep moving until an external force stops it too, the brakes of the car. So if you're approaching a stoplight or a traffic light, and if the light turns red, then you know you have to stop. Then you have to hit the brakes, and your car will also stop. Third example. So let's say there's a car that's going through a highway again, and it's in uniform motion, so it keeps moving. The only problem is there's a rock, but the driver doesn't see it. So what happens? The car will stop. Here again is another example of the first law of motion. Again, the car will move at a constant motion or a uniform motion until it hits something. And that's how simple the first law of motion is. Second law of motion. What really is in this equation of the second law of motion? Force is equal to mass times acceleration. Well, the second law means the law of acceleration.
Hi guys, I just realized while editing this video that I said something wrong, so I'll just repeat and clarify. So the second law is known to be the law of acceleration, not means the law of acceleration.
It states that an object's acceleration depends on 2 things: the net force acting on the object and the object's mass. In order for us to understand fully what it's trying to say, we have to unlock some terms. First is acceleration, the second is net force, and the third is mass. Acceleration is how fast an object can gain speed. Net force means the total amount of force acting upon an object. So for example, we have a box. Let's represent it with this stuffed toy again. And if a person is pushing one side for 5 newtons, newtons is the measurement for force. So if one person is pushing from the left in 5 newtons and another person is pushing towards the right for 5 newtons also, it cancels out because pushing left, so negative, and pushing right means positive, and they both have the same value, so it equals to 0, and the box doesn't move. Just a quick recap. Going north or going up means it's positive. Going right or east means positive also. Going south or going down is negative, and going to the left or west is negative. And the last term is mass, the stuff that makes up an object, the stuff that makes up the particles of the object. In order to explain the second law of motion properly, I invite you to Daphne's Playground. Daphne's Playground is a new segment of my videos in which I use Daphne's toys or my little sister's toys for demos.
Hi everyone, welcome to Daphne's Playground, and I am voiceover Denise here, and this is our first example. The first example is a bike and a car. If I would push them both with the same force, what do you think will move further? Would it be the motorcycle or would it be the car? Please also take note that the car is way heavier than the bike. And from this example, I push it at the same force, but the motorcycle moves more because it is lighter than the car. Our second example is two bikes. They're exactly the same except different color, but one will be on the floor and then one will be with a carpet. The carpet I'm using here is a scarf that I made. The scarf would add more force. It has more friction because it's more rough than just the floor itself. Let's see what happens if we push them at the same time and the same force, but on different surfaces. And you can see from that push that the one on the carpet didn't move as far as the one that was not on the carpet. Our next example is two identical bikes. I will push them at different forces so we can see what will happen. As you can see from that push, the one that I pushed further or with more force went further. As you can see from the experiments, we now know that everything depends on these three variables, which is force, mass, and acceleration.
Summarize all the demos that I showed you earlier. There's an equation for the second law, and you might have heard it. It's force is equal to mass times acceleration. The terms used here are force is equal to F, m is equal to mass, and a is equal to acceleration. So if I have this stuffed toy, and if I apply more force to it, that means it will accelerate more. And this term that we use for this is called directly proportional. Because if you add more to one variable or one thing, then the other thing will also go up. So more force, it equals to, it can move faster, more acceleration. This goes the same as for force and mass. If this has more mass, you also need to add more force so that you can lift it up. And the two things here that are inversely proportional, meaning that one variable goes up and one variable goes down, is mass and acceleration. If you have more mass on an object, that means it can accelerate slower. One goes up, one goes down. Congrats! You made it through the hardest law, the law of motion. And from now on, I'm pretty sure you'll be able to understand the last law, the third law of motion, which is the law of reaction. In this law, it states that for every action, there is an equal and opposite reaction. Have you ever wondered why if you punch a wall because you're so frustrated and you just want to hit something, but you end up hurting yourself? Because when you hit the wall exerts the same amount of effort that you put into it. So if you hit the wall at 5 newtons, the wall will also exert the same amount of force back to you, 5 newtons again. And that's why your hand starts to hurt after you hit a wall. And this leads us to our first example. When a car is on a bridge, if a car is on a bridge and exerts 5 newtons downwards to the bridge, then the bridge will also contradict to that force, and it will hold the car in place. 5 newtons down, then 5 newtons up as well. That's why the bridge stays that way. But what happens if the bridge exerts less force than the car? If the car exerts 5 newtons to the bridge, but if the bridge exerts only 4 newtons because it can't carry the weight of the car, then the bridge will collapse. And that's why there are weight limits for bridges, so that even if a lot of cars go pass by the bridge, hopefully the bridge won't break. And thank you everyone for watching. Sorry if this science class was a bit more technical than usual, and I guess more choppy because I'm actually kind of nervous for this one, and it's kind of hard to explain the 3 laws of motion in a very short video. And please check out Mark Grober's channel because he's really awesome. Thank you for joining my science class. Please hit the like button, turn on the notification bell so that you get notified when I post new videos. And please don't forget to subscribe so that you'll keep seeing amazing content like this. And you know, thanks so much for watching my video again. And please stay safe from the coronavirus. Just stay at home, even if it may be boring. Might learn a new talent, or just answer your schoolwork if you have online school. Good thing for me, I don't have classes anymore. It's summer for me, but just enjoy your summer or your school because you may never know when it will end. So, thanks again. Stay tuned for the next video. Hope that was the same. I can't talk anymore. In order to explain the